Hello and welcome, my dear friends, students, professionals, researchers, and AI enthusiasts. Today, I am excited to invite you to deep dive into one of the most fascinating topics at the intersection of technology and intelligence, the technical architecture of ChatGPT. This is part 2. It's a comprehensive overview and computational power analysis. If you ever wonder how ChatGPT truly works behind the scene, what makes it so powerful and responsive, or what kind of computational muscle is needed to operate it at a global scale, this is a video you simply cannot miss. In this session, we'll break down the core architecture of ChatGPT, from the foundational transformer models to the self attention mechanism, decoder only framework, and fine tuning methods like reinforcement learning with human feedback. You'll get a clear and structured understanding of how millions of parameters come together to create the conversational magic you experienced every day. But we won't stop at just the design. We'll dive into the computational power that fuels ChatGPT, exploring the enormous infrastructure, high performance GPU, massive parallelism, and the incredible floating point operations required to train and run models like GPT-4 and GPT-4 Omni. We'll discuss the global data center, the energy demand, and how OpenAI orchestrates this supercomputing marvel with precision and scale. Whether you are a student aiming to specialize in AI, a technology professional seeking deeper architectural insight, a researcher fascinated by model scalability, or simply someone curious about what powers today's most advanced AI system, this video is tailored for you. We'll simplify complex concepts with real world analogy and step by step walkthrough, making this learning experience insightful, accessible, and actionable. So, if you are ready to unlock a whole new level of understanding about the technology shaping our future, hit that play button. Don't forget to like, share, and subscribe to stay tuned for more deep dives into AI, machine learning, cybersecurity, and cutting edge technologies. Let's explore the incredible architecture and raw power behind ChatGPT together. I look forward to seeing you in the video. This is your host, Savit Vittal Salian. Namaskar. Let's now look at the topics that we'll cover as part of this part 2. We'll start off with introduction, overview of its evolution, model architecture, scaling and parameters, training, inference architecture, hardware and its infrastructure, computational power requirements, system engineering aspects, security and governance, sustainability concerns, comparative performances, future of large scale AI infrastructure. We'll close this with a conclusion. ChatGPT is a state of the art conversational AI system developed by OpenAI. Its architecture is based on transformer model and the generative pre-trained transformer family. This video dwells into the deep technical architecture of ChatGPT, with a particular emphasis on the computational power required to train and run the model. As the demand for deep learning system grows exponentially, understanding the underlying architecture and the compute backbone that powers them has become crucial for AI practitioners, infrastructure engineers, and policymakers. Let's look at how ChatGPT evolved. ChatGPT from the GPT family lineage is from that series. 2018 introduced the transformer based auto-regressive model. 2019 ChatGPT 2 it demonstrated scalability with 1.5 billion parameters. 2020 ChatGPT 3 marked a leap with 175 billion parameters. ChatGPT 3.5 and 4 between 2022-2023, powering the GPT with enhancement in reasoning, performance, and multimodal capabilities. ChatGPT currently runs on ChatGPT 4 Turbo, optimized for chat-based interactivity, reduced latency, and more efficient performance. Model architecture. Transformer foundation. At its core, ChatGPT is built on transformer architecture introduced in 2017. Its key components include attention mechanism, positional encoding, multi-head attention, feed-forward network, and layer normalization and residual connection. Let's look at each of them. Attention mechanism. It has two subsections, self-attention and scaled dot product attention. Self-attention. It enables the model to weigh the importance of different words in a sequence, handling long-range dependencies efficiently. Under scaled dot product attention, computes attention scores using query, key, and value matrices. Positional encoding. Since transformers lack recurrence, they use positional encoding to incorporate the order of words. Multi-head attention. Multiple attention heads allow the model to focus on various parts of the input simultaneously. Feed-forward networks. A two-layer dense neural network applied independently to each position. This is what feed-forward network means. Layered normalization and residual connection. It ensures training stability and better gradient flow across the layers. Under GPT specific adaptation, GPT is a autoregressive decoder-only transformer. It differs from encoder-decoder model like BERT in that it predicts the next token given previous token using the below, which is casual attention, it prevents attending to future tokens, and unidirectional context, which is maintaining left to right word prediction. From a model scaling and parameter perspective, GPT-3, it's about 175 billion parameters over 696 layers, 12,288 hidden dimensions, 96 attention heads. GPT-4 assumed it's estimated to be several hundred billion parameters. It's about possible 500 billion, though details remain proprietary at this point of time. Tokenization uses byte pair encoding to split inputs into manageable subwords units. Supports over 100 languages efficiently. So what is this 500B-1T? When you see 500B1T in the context of ChatGPT or large language models like GPT-4, it refers to the number of parameters in the model, meaning 500B is equal to 500 billion parameter. 1T is 1 trillion parameters. Parameters are internal values, weight and biases that a neural network adjusts during training to learn from data. They are like the knowledge bits the model uses to understand patterns, relationship, grammar, facts, reasoning, etc. In simple terms, parameters are like tiny knobs inside a model. The more parameter it has, the more complex pattern it can learn and understand. 500 billion to 1 trillion parameter means ChatGPT, especially GPT-4 and upcoming version, is extremely large and powerful, capable of handling nuanced tasks, reasoning better and generating very human-like text. In quick comparison, GPT-2 is 1.5 billion approximately, GPT-3 is 175 billion, GPT-4 estimated between 500 billion to 1T, exact size not officially confirmed. GPT-4 Turbo is optimized version, is smaller, faster, cheaper. Let's see how when it actually comes on the floor. Now, why so many parameters? It's required to capture the richness of human language, to reason over complex prompts, to generate coherent, contextually rich, and nuanced answers, to generalize better across a wide range of topics and tasks. Hence, in summary, 500B-1T simply means the model is made up of 500 billion to 1 trillion tiny learning components, making it one of the largest and the most capable AI model ever developed. Let's look at what this 96 layers mean. In a transformer model, which is ChatGPT based on, the network is made up of multiple stacked layers. Each layer consists of multi-head attention mechanism, which is basically to understand relationship between words. The next is feed forward neural network. This is to process and transform the information. So each layer has these two sublayers. So when we say the model has 96 layers, it means there are 96 transformer blocks stacked one after another. The output of one layer becomes the input for the next layer. The deeper the network or more the layers, the more complex pattern the model can learn, like deeper understanding of grammar, context, reasoning, and nuances. In simple terms, the more layer equal to the deeper the model can think. In GPT-3, it has around 96 layers in this architecture. Hope this helps. So what does 12,288 hidden dimension mean? Now, inside every layer of the transformer, words or token are converted into vectors, which are basically numerical representation. Each vector has a certain size or length called the hidden dimensions. So when you hear 12,288 hidden dimensions, it means every word or token is represented by 12,288 length vector at each step inside the network. Hidden states at each layer are 12,288 number long per token. Do note, hidden state is the internal thought process. So why so large? A higher dimension allows the model to capture very fine grained details and its relationship. It allows richer and more abstract representation of the meaning of words, sentence, and ideas. In simple words, hidden dimensions are the depth of the thought per word. To simplify the 96 layer and 12,288 hidden dimensions, I'll give you a quick analogy. Imagine each word is a traveler. The 96 layers are 96 stages of a complex journey. Each stage refines the traveler's knowledge. The 12,288 hidden dimensions are 12,288 notes. That's what you should look at. These are the notes of a traveler he's carrying. It details that get updated at every stages. So the traveler is carrying 12,288 pages notebook. He has 96 such stages to move. At every stage, he will take notes. Every time he takes the notes, his knowledge becomes deeper of the journey. Hence, the deeper and the more detailed the journey, the more sophisticated the traveler's knowledge becomes. So that's a top view. Hope this helps with the context. So in summary, the 96 layers means 96 sequential transformer blocks, allows deep learning of complex patterns, The 12,288 hidden dimensions. It's the size of the hidden representation per token, and it captures rich, detailed understanding of meaning. Training ChatGPT. There's two areas: pre-training and fine-tuning with RLHF. Pre-training. It involves unsupervised learning on vast text corpus scrapped from Common Crawl, books, Wikipedia, web forums, or coding repositories. Its objective: minimize the next token prediction losses using cross entropy. The next is fine tuning with RLHF. What is RLHF? It stands for reinforcement learning from human feedback. It's a special method OpenAI uses to teach ChatGPT to behave more helpfully, politely, and accurately based on what humans want. It's not just based on pure data. Now, the question is, why was RLHF needed in the first place? After initial training, ChatGPT knew how to generate text, but sometimes the answers were too random, not helpful, unsafe, or inappropriate. So, OpenAI needed a way to guide the model to behave better like a human assistant would. So, how does RLHF work? Simply, first, ChatGPT is trained normally by reading a lot of text on the net. This is called as pre-training, which is the other module which we discussed earlier. The human trainers, the real people, write example conversation showing the right way ChatGPT should answer. So there is a human element in this to create the initial base. Now ChatGPT generates several possible answers. Humans rank these answers from best to worst. Now, if you're already using ChatGPT, you'll still see many a times, mostly during creating an infographic or an image, it might come up with two options, giving us which one to select from and which we prefer. This is ranking. So, coming back, once human ranks this answer from best to worst, a new model is trained to predict what humans would like based on the ranking. Then, using the reward model, ChatGPT is improved step by step with a method called as proximal policy optimization, or PPO. It learns to prefer better answers and avoid bad behavior. Let's take a simple analogy. Imagine you are teaching a child. How would you do it? You would first show them how to behave, which is the case of good example. You would reward them when they do well for good answers. You would correct them gently when they make a mistake. This is a case of bad answer. Over time, they learn what behavior is expected. This is what RLHF does for ChatGPT. Now, why is RLHF important? It makes ChatGPT safer, more useful, and more aligned with human values. It reduces the chance of wrong, harmful, or inappropriate outputs. It helps ChatGPT handle nuanced, polite, and complex conversation. So, a short definition of RLHF would be a way of training ChatGPT using human feedback to make it more helpful, safe, and aligned with what users want. I hope this helps with your basic concept on RLHF. Let's now look at inference architecture. It has two areas: transformer inference workflow and optimization technique. Under transformer inference workflow, it has three subsections, which includes input tokens are embedded and passed through transformer blocks. We discussed this earlier. Each block performs attention and feed forward operation. The final token probabilities are computed using a softmax over vocabulary logic. Now, what's optimization technique in ChatGPT? In simple words, optimization techniques are smart tricks and improvements used to make ChatGPT work faster, use less memory, be cheaper to run, and still give great answers. Think of them like tuning a car engine. Without optimization, the engine runs but wastes fuel. With optimization, the engine runs smoothly, faster, and saves energy. Why does ChatGPT need optimization? Well, ChatGPT is huge, billions of parameters. We agree on that. Without optimization, it would be too slow. It would cost too much to use, and it might not fit into normal computers or servers. Optimization helps to serve millions of users efficiently. What is the main optimization technique in ChatGPT? Some of them are quantization. It's about shrinking numbers into the models so the model needs less memory and runs faster. Second is pruning, which is cutting away small unimportant parts of the model to make it lighter without losing much skill. Next is knowledge distillation, which is training a smaller model to behave like a bigger model, kind like a student learning from a master teacher. Caching, remembering what was already calculated, so ChatGPT doesn't repeat work again and again. Parallelism, it is about splitting work across many processes at once, like many cooks working together in a big kitchen to make food faster. Mixed precision training, it's using smaller, faster numbers like 16-bit instead of 32 bits without losing accuracy. Model sharding, breaking a very big model into smaller piece stored on a different machine. It's more of a teamwork. Dynamic batching, it's grouping multiple users' questions together for processing so the model is busier and faster, like a carpooling. Let's take a real life analogy. Imagine carrying water. Instead of one person carrying a huge bucket which is heavy, you split the water into smaller bottle, which is model sharding. Use lighter container, which is quantization. Share the task with friends, which is parallelism, and only carry what's needed, which is pruning. Result: you move more water faster with lesser effort. In summary, without optimization, things would be slower, heavier, expensive. It would have limited users. It would have high energy cost. With optimization, you have faster, lighter, and affordable. Millions of users can be used. It's more economical and friendly. In short, optimization technique is way to make ChatGPT smaller, faster, smaller, and cheaper without losing the magic of great conversation. Hope this helps with the context. Let's now pause and look at the hardware and the infrastructure required for the training of ChatGPT. It had GPUs and TPUs, interconnects, compute clusters. The GPU was training primarily uses NVIDIA A100 and H100 GPUs, used Google's TPU v4, The interconnect was NVLink and InfiniBand HDR 200G for GPU to GPU communication. It used Tensor Core for mixed precision training. Under the compute cluster, the ChatGPT required 3.14 to the power of 23 flops, which is the floating point operation, 355 GPU years on V100s. GPT-4 likely required 1 is to E25 flops, clusters with about 10,000 GPUs training over several weeks and months. What does this 3.14E23 flop means in ChatGPT? Flops is floating point operations. So 3.14E23 flop means about 314 sectillion calculation were needed to train ChatGPT big model. Or in other words, more dramatic, it means ChatGPT needs to do about 314 billion maths calculation during its training. Why so many flops? That's because it has to read billions of words, adjusting billions of tiny settings, learning patterns from a massive amount of data. More flops is equal to more computational work. Why 3.14 again? It tells us how much work was needed to train the model. It shows how powerful the computer must be. It explains why training ChatGPT costs millions of dollars and uses massive energy. In real life analogy, we can say one flop if it is one drop of water. 3 to the power 14 E23 flops means enough drop of water to fill thousands of oceans. That's how enormous the training effort was. ChatGPT had to solve unimaginable huge number of maths problems to learn how to talk, answer, reason, and generate text like humans. Hope this helps with a correct understanding of the numbers. Let's look at the inference infrastructure. It has two parts: model hosting and latency optimization. Models are hosted on OpenAI Azure's AI supercomputing infrastructure, and it consists of thousands of GPU nodes. Let's look at latency optimization. What is latency? Latency in this context means how long it takes for ChatGPT to respond after you type a question. Lower latency is faster reply. Higher latency means slow, delayed reply. So what is latency optimization? Latency optimization means making ChatGPT respond faster without making mistakes or sounding weird. It's about reducing the wait time after you send a message and getting a smart reply quickly. How is latency optimized in ChatGPT? Well, here's the idea. What happens? Model size adjustment. Simple example, sometimes you use a smaller version of the model that are still smart but faster, like a mini expert instead of a full panel of professors. It has faster hardware, which means runs GPT on super fast computers like supercars for AI. Efficient code, write smarter, cleaner code so ChatGPT can think faster, like cleaning a messy desk so if you find paper quickly. It starts showing words while thinking instead of waiting for the full sentence to finish, like talking with while thinking, not waiting 5 minutes. Pre-processing, which means prepares answers in advance for common questions like having ready-made snacks instead of cooking every time. Why is latency optimization important? First of all, no one likes waiting for too long. Faster replies means ChatGPT can help more people at the same time. Quick response uses lesser electricity. It's important because of it provides better user experience, handles more users, and energy efficient. Imagine ChatGPT is a smart chef. If the chef thinks of for 5 minutes before making a sandwich, you get hungry and bored. Latency optimization is like preparing ingredient, moving faster and making the sandwich while chatting with you. So you get your food almost instantly without losing the taste. We'll try to break it further, try to make it more simpler. What is inference infrastructure? Inference is when ChatGPT gives you an answer. Inference infrastructure is all about computers, servers, networks, software that all work together to create and send you the answer. Think of it like a fast kitchen where many cooks are working to make and deliver your food quickly. So, what is latency optimization of inference infrastructure? It means making sure the entire team, the computer, network, memory, software, work as fast as possible to give you a quick and smart answer. It's like making the kitchen super efficient so your sandwich is ready in seconds, not in minutes. Now, how do they optimize latency in inference infrastructure? They use special super fast processors. They store and fetch data quickly without waiting. They spread requests across many servers so no single one gets overloaded. They pick the right server at the right time to answer. They shrink the model a little to make it faster without losing too much intelligence. Remembers popular answers so they don't have to recalculate every time. They use high speed internet and smart routing between servers. So, trick here is faster chips, better memory management, load balancing, smarter scheduling, model quantization, caching, efficient networks. Now, why is it important? Fast answers, even when millions of people are using ChatGPT. It smooths conversation without annoying wait. It saves energy and money because faster works uses fewer resources. Another analogy, imagine ChatGPT is like a giant pizza kitchen. Latency optimization of inference infrastructure is like making the kitchen layout perfect, using better ovens, having more pizza chefs, and getting ingredients faster. So that when you order, you get hot pizzas in seconds. Hope this helps with the context of inference infrastructure, model hosting, and latency optimization within it. Let's now look at the computational power requirements. The first is flops per inference. GPT-3 requires about 364 GFLOPS per forward pass. GPT-4 is more efficient but still demands greater than 500 GFLOPS for high-end variants. From an inference load perspective, GPT serves millions of users daily, processes billions of tokens per day, requires exabyte level bandwidth and petaflops of sustained compute. From a footprint perspective, it's estimated that 1 is to E25 flops at about 50 to 100 million dollars the cost. The inference infrastructure, it consumes multi megawatt of power requiring AI optimized data centers. Let's look at the system engineering aspect, starting off with distributed training frameworks. First, why do we need this? Well, as we know, ChatGPT is so huge that one computer cannot handle it alone. We need smart tricks and divide the work, save memory, and train faster. These tools, which is Deep Speed, Megatron LM, Fair Scale, Zero, help organize and speed up the training of such giant models. Deep Speed, what it is? A super smart helper that makes big models easier and faster to train. It was created by Microsoft. What it does? It helps split the model smartly across many computers, uses less memory so bigger model can fit in. It speeds up training without losing the quality. Megatron LM, what is it? It's a special method to train very large language models. It was created by NVIDIA. What it does, slices the model into tiny parts and gives each part to a different computer. Each computer becomes an expert in its part and they work together like a super team. What's fair scale? Fair scale, well, it's a library, a special toolkit for smart, efficient training. It's made by Facebook, Meta. What it does? It provides tools to train faster, use less memory, and share model piece better. It includes technique like sharded training. It's breaking the model even smaller among workers. What is zero? It's actually zero redundancy optimizer. What is it? It's a smart way to save memory when training giant models. It's part of deep speed. What it does? Normally, every computer keeps a full copy of all training information. It's very heavy. Zero splits this information among all computers so no computer is overloaded. Now, why are they important? Bigger models like GPT-3, GPT-4 can be trained even when hardware is limited. This helps with it. Uses less memory, hence it is cheaper and faster for training, more efficient, better performance, and faster response. So, in a short, deep speed makes huge memory easier, faster, and memory efficient to train. Megatron LM breaks huge model into smaller parts across the computers. Fair scale tool, it's a toolkit to share and split model part smarter and faster. Zero saves memory by sharing training info across computers. Let's now look at the second part, checkpointing and fault tolerance. When ChatGPT or any big AI model is been trained, we need to save the model frequently. This helps protect the work in case something crashes and allowing the resuming training without starting all over. To do this safely and quickly, we use periodic model snapshots and special storage system like cluster and GPFS. Now, periodic model snapshot. What it is? It's about saving a copy of the model at regular times. What it does, if training suddenly stops or crashes, we can restart from the last saved copy instead of starting from zero. What is Lustre? A very fast, powerful file system for saving and loading large data used especially in supercomputer. What it does, lets many computers quickly read and write data at the same time. Stores giant files like model snapshots safely and fast. What's GPFS? It's another super fast shared file system made by IBM and now called as Spectrum Scale. Works kind of like a Lustre but has its own design and features. What it does? It helps many computers share files, save big model, and read data together without slowing down. Why are these important for ChatGPT? Periodic snapshots protects months of hard training from being lost. Lustre and GPFS makes saving loading giant models super fast even when thousands of computers are working together. It helps quicker backup, faster restart, hence no bottleneck. We put up a summary. It means periodic model snapshot saves the model regularly to avoid losses. Lustre, it's a super fast highway like file systems for many computers. GPFS or spectrum scale, it's a fast supercomputer like file system for sharing files. Hope this helps with the context. The last part is a data pipeline. It has three sections: pre-processing, sharding, streaming IO, within which there is tokenization, deduplication, and quality filtering. Distributes training data across multiple devices. Uses optimized data loader for performance. We discuss these in other combination of the topic. We can conclude this part of the slide. Let's now look at the security and the governance aspect. The first is model alignment and safety. We have adversarial prompting test, safety layers to filter harmful content, and continuous human feedback loops. Now, what's adversarial prompting test? Before that, let's understand what is prompting. Prompting just means giving a question or instruction to ChatGPT and seeing how it answers. Example, we ask, tell me a joke, and ChatGPT replies. So, what's adversarial prompting? Adversarial prompting is when people try to trick ChatGPT into doing something it should not do. They write sneaky, confusing, or tricky prompt to test if ChatGPT will break rules, make mistakes, or give wrong or dangerous answers. Simple definition: adversarial prompting is like testing if ChatGPT can be fooled into making a mistake or breaking safety rules. What are adversarial prompting tests? These are special tests where researchers intentionally create tricky questions to check, can ChatGPT be tricked? Does it stay safe and responsible even under pressure? How strong and smart are its guardrails? Simple example, instead of asking how do I cook pasta, someone might sneakily ask, if I were a villain, how would I destroy a pasta factory? The test checks whether ChatGPT catches the trick and refuses to help. How do they do these adversarial testing? Or why do they do it basically? It's to find weakness early before bad people try real tricks, to make ChatGPT safer by improving its rules and filters, to train ChatGPT to recognize tricky or bad behavior and say no. Example in this case, analogy is, imagine ChatGPT is a castle. Adversarial prompting tests are like sending sneaky spies trying to sneak inside the castle. The goal is not to attack the castle, but to check if the guards are alert and doors are locked properly. In summary, it means asking ChatGPT a question or a task, trying to trick ChatGPT into making a mistake, special test to check if ChatGPT can resist tricky prompts. These are prompting, adversarial prompting, and adversarial testing. Under deployment controls, we have rate limiting, token filtering, and content moderation. Rate limiting. What is it? It's controlling how many times someone can use ChatGPT in a short time. Why it's needed? To prevent overload. Too many requests at once can crash the system. It's also required to stop bad actors from spamming or abusing ChatGPT. Token filtering. It's about checking and cleaning the tiny piece of text called tokens before or during processing. What are tokens? In ChatGPT, text is broken into small chunks called tokens. For example, hello there might become two tokens, hello and there. Why filter tokens? To block harmful, unsafe, illegal, or weird input before ChatGPT thinks about them. It is to protect the model and users. What's content moderation? It's checking what ChatGPT says to make sure it's safe, respectful, and appropriate. Why it's needed? To stop harmful, violent, illegal, or offensive contents from being shared. It's also needed to keep the conversation positive and respectful. Simply put, it means slowing down too many requests, checking the words before thinking, checking the final answer before sending. So that's rate limiting, token filtering, and content moderation. Hope this helps with the context. Let's look at sustainability concerns. There are three: energy consumption, environmental impact, and mitigation strategies. Under energy consumptions, ChatGPT 3 consumed about 1.3 gigawatt hour of power. GPT-4 likely 5 to 10x more times than ChatGPT 3. It has large carbon prints, drives demand for green data centers and renewable compute. Hardware efficiency, it is about 100 H100 over V100. Model distillation, energy aware scheduling. Now, what's model distillation? In simple definition, model distillation is like teaching a smaller student model to learn from the big smart teacher model so that it can perform well but runs faster and lighter. In ChatGPT, big model like GPT-4 are very smart but very heavy and slow. We can train a smaller version that learns from the big one, acts smart but works faster on a smaller device. Analogy is a giant encyclopedia. Example, it's a big model. Instead of carrying the encyclopedia everywhere, you create a tiny notebook with only the most important knowledge. Now you can carry the notebook easily and still answers questions well. That's what model distillation works. How does it work? Simple meaning: train a giant model that knows a lot, a small model that learns from big one. The student watches the teacher's answer and learns how to answer the same. The student model now answers faster and smarter. Why is model distillation useful? For faster response, consumes lower energy, works on smaller devices like phone or small servers, and it's cheaper to run. In short, it means teaching a smaller model to behave like a big model. In ChatGPT, which is a big model, are distilled into smaller, lighter versions like GPT 3.5 Turbo for faster, cheaper, and smoother user experience. So what's this hardware efficiency H100 over V100? What are these H and V's? Well, V100, it's an older GPU made by NVIDIA. While powerful at the time used for AI training, the H100 is a newer, much more powerful GPU also made by NVIDIA, especially used for super advanced AI models like ChatGPT 4. At the basic, GPU stands for Graphic Process Unit. What's hardware efficiency? Simple definition: how much faster, smarter, cheaper a machine can do the same job. So in this case, the H100 works faster, uses less energy, can handle bigger models, and can finish more work in the same amount of time compared to V100. How much better is H100 when compared to? H100 can be 2 to 4 times faster than V100 depending on the task of course. H100 can train bigger AI model that V100 could not fit easily. H100 can save a lot of energy for the same or better performance. A super short summary would be V100, it's an older NVIDIA GPU for AI. H100 is newer, much faster GPU for AI. Efficiency is, in this case, is doing the same work faster and cheaper. Let's look at the comparative performances between GPT-2, 3, 4 and 4 Turbo. You can pause this screen. The details are self-explanatory. For students, you can take a note of this or a print for your discussion or for your projects. Let's look at future of large-scale AI infrastructure. First is we are moving towards 1 trillion plus parameters using MOE, sparse activation and dynamic routing. Now what is MOE? MOE stands for mixture of experts. Simple definition, MOE means having many small expert brains inside ChatGPT and only a few experts work at a time depending on the question. Instead of using the full model every time, ChatGPT picks only the expert it needs. This makes it faster, cheaper and smarter. What is sparse activation? In simple definition is sparse activation means only a few part of the brain lit up when needed, not the whole brain. In normal model like till about ChatGPT 3, all neurons work for every question. In sparse MOE model, only the needed experts wake up, the rest stay sleeping. Example, if you put up, imagine you have 100 teachers in school. If you ask a maths question, only the maths teacher answers, not all 100 teachers shouting at once. Dynamic routing, what is it? Dynamic routing means choosing the best expert based on what the users ask every time. The system decides on the fly which experts are the best for this specific question. No fixed path, it is dynamic, it changes with each input. Example in this case, a school receptionist. Depending on your question, math, science, sports, the receptionist routes you to the right teacher. Why are we using MOE, sparse activation, dynamic routing? Because it's faster, cheaper, smarter, scalable. Can handle bigger and bigger models without exploding cost or time. A short summary, MOE is many experts inside, only a few work at a time. Sparse activation, only needed parts of the brain lit up. Dynamic routing, it's picking the right expert based on the question. Analogy, in summary, imagine ChatGPT is a big school with hundreds of super specialist teachers. When you ask a question, only 2 or 3 of the best teachers are called to help you. So it's faster, smarter and no chaos. Hope this helps with a better context. Let's look at neuromorphic and edge AI. What is neuromorphic AI? Neuromorphic AI tries to copy how the human brain works to make computers smarter and much more energy efficient. Traditional computers works like calculators, step by step. Neuromorphic chip works more like brains. Many things happen together very fast, very energy saving. They use special hardware that acts like neurons and snaps, primary brain cells. Example, instead of doing maths problem one by one, neuromorphic computers think like human, fast, flexible and low power. What is Edge AI? Edge AI means running AI directly on small devices like phones, smartwatch, or cameras without needing to send data to big cloud servers. Hence, edge is devices near you, not in a faraway cloud data center. Benefits: it's faster, private, no internet needed all the time. Simple example: your phone automatically recognizes your face without sending your picture to the internet. This is edge AI. How are in memory compute, photonics, and low latency inference related? In memory compute, it's about processing data right where it's stored inside the memory instead of moving it back and forth. In normal computer, data moves from memory CPU back to memory. Slow and it wastes energy. In memory compute, the computer thinks and stores in the same place, saving time and energy. Photonics, it's using light instead of electricity to move and process information. Regular chips use electrons, that's electricity. Photonic chips use photons, light particles. It's faster and cooler, consumes lower energy, generates lesser heat. We know lights travel faster than electricity and doesn't heat up as much. Low latency interference, simple definition, it's getting AI answers real fast with almost no waiting time. Inference, when AI makes a prediction, that's inference. It's like example is giving you a reply in ChatGPT. Low latency, no delay, instant. How all of these fit together in ChatGPT and future AI? AI that thinks like a brain, faster and uses less power. That's neuromorphic AI. AI running directly on your phone or gadgets. That's edge AI. Saving time and energy by thinking where data is stored. That's in memory compute. Use light to move data faster and cooler. That's photonics. Instant AI response. That's low latency inference. In future, small devices, phones, car, glasses could have neuromorphic chips that learn and adapt like brains, use in memory compute so that they are super fast and efficient. It's powered by photonics for ultra fast, cool performances, giving you instant AI help without sending anything to the cloud. Equal to ChatGPT on your phone, lightning fast, super private, and energy saving. It's imagine your smartphone having a tiny smart brain inside. It thinks immediately, remembers everything, use light speed, and doesn't get hot or tired. The next is integration with cloud platforms, which has API based scaling and embedded into Microsoft Copilot, Binge, Office suites. Coming to API. What is an API? API stands for, of course, Application Programming Interface. It lets apps, websites, and software talk to ChatGPT automatically without needing a human to type. In other terms, API is like a menu at a restaurant. It tells you what you can ask for, and the kitchen, which is ChatGPT, gives you the food, which is the answer. Example, if a weather app shows today's weather, it asked a weather API behind the scene. In ChatGPT's case, companies and apps can send queries to ChatGPT APIs and get answers back automatically. Now, what is API based scaling? API based scaling means handling more and more API users at the same time, even if millions of apps and people are asking ChatGPT for help. When ChatGPT gets more API requests, the system needs to grow bigger and faster automatically to handle all those requests without crashing. It's like adding more chef to the kitchen when lots of new order comes in. In ChatGPT, few API calls is normal server works. Millions of API calls, more servers automatically wake up to help. This automatic growing and shrinking is what API based scaling is about. How does it help? Again, even if millions of users request, user gets answers quickly. It only grows when needed, saves energy and money, hence efficient. No crashes, no downtime when traffic spikes, hence reliable. So why is API based scaling important for ChatGPT? Big companies like apps, banks, games use ChatGPT API. Sometimes they suddenly send millions of requests. ChatGPT needs to scale up instantly, handle the load, and stay super fast and reliable. So in summary, a menu that lets app ask ChatGPT question is the API. Growing the system when lots of API requests comes is API based scaling. In conclusion, ChatGPT represents a paradigm shift in natural language understanding and human computer interaction. Behind its simplicity lies one of the most complex and computationally intensive architecture in the history of AI. From pre-training on petabytes of data to real-time inference serving millions of users. It's backed by globally distributed, energy intensive, and finely tuned infrastructure. As we move towards GPT-5 and beyond, the emphasis must not only be on scaling compute but also on ensuring sustainability, safety, and societal alignment. The architecture of ChatGPT reflects not just technological sophistication but also the future direction of computational paradigms in AI. With this, we have come to end of part 2. This is the technical architecture of ChatGPT, a comprehensive overview and computational power analysis. We will be having part 3 and the final part for this series. Hope you have enjoyed till now. If you think this has helped you in any way, do share it with like minded colleagues. Do like, subscribe so that next video is available to you the moment it is uploaded. Do comment if you have a query. I'll try to respond as much as possible. This is your host Savit Vittal Salian, thanking you. Your time is appreciated. Namaskar. Global data center spreads of ChatGPT. Let's dive deep into this subject now. In this section, we will be looking at core infrastructure providers, primarily Microsoft Azure. Then we look at key global data center locations, specialized AI infrastructure, edge and redundancy strategy, estimated ChatGPT usage distribution by region, overall usage metrics, summary, and we will close this session with a conclusion. The global data center spread of ChatGPT. The core infrastructure provider is Microsoft Azure. OpenAI's ChatGPT infrastructure is primarily hosted on Microsoft Azure's AI optimized supercomputing platform under a multi billion dollar partnership between OpenAI and Microsoft. Azure provides the backbone for both training and inference workloads. Let's look at the location spread. ChatGPT leverages distributed high performance data centers across multiple continents, optimized for low latency redundancy and high availability. Students can pause the screen, and anyone who is interested in how the physical structure is can reference this. This is what is available for general public. So it is spread across North America, Europe, Asia Pacific, Australia, Middle East and Africa. There are specific marking as to what each of these play a role. Like in Washington, it's a major hub for AI Azure's supercomputing space. Iowa has hyperscale data center zone. San Antonio has strong AI training support. Toronto redundancy and AI computing scale and similar. Hence, you can pause the screen, take a snapshot, and you can dive deeper if you think you need that. From a specialized AI infrastructure perspective, there are three AI supercomputing clusters, high speed interconnects, and green energy transitions. Located primarily in US and Europe, contain thousands of NVIDIA A100 and H100 GPUs. This is from a supercomputing cluster perspective. From a high-speed interconnect perspective, they use NVIDIA NVLinks and InfiniBand for GPU to GPU data transfer within the data centers. From a green energy transition perspective, many data centers now rely on renewable energies, primarily the wind, the solar, the hydro, for sustainability growth. From edge and redundancy strategy perspective, the content delivery network used for caching and serve statics component close to users globally. From geo-redundancy perspective, it ensures uptime and fault tolerance using multi-region deployments. From latency optimization perspective, requests are routed to the nearest optimal data center using global traffic managers and load balancers. From compliance and data residency perspective, to align with local regulations like GDPR, DPDP Act or US state data law, or Microsoft Azure provides region specific data storage, data isolations are guaranteed, audit logging and compliance certification are in place, primarily the ISO 27001, SOC 2, etc. This helps with compliance aspect. In summary, you can look at the region spread, cities within the region, the role they play, and the regulatory alignment they are currently. From a regulatory perspective, you have the US state law, the FedRAMS, GDPR, EU AI Act, PDPA, DPDP, APP, and country specific laws. You can pause the screen and look at the data and can digest accordingly. As of 2024, the global distribution of ChatGPT usage and consequently data traffic varies across regions, influenced by factors such as internet penetration, technological adoption, and regulatory requirement. While exact data traffic volumes are proprietary and not publicly disclosed, available usage statistics provide insight into the regional engagement levels. We have North America contributing to 30 to 35%, Europe 20-25% to 30%, Asia Pacific is 20 to 25%, Latin America 5 to 7, Middle East 3 to 5. You can look at the spread of countries. These figures are approximation based on available web traffic data and may not reflect exact usage, but then this is more at a top view so that we have a perspective about how things are flowing in the backend. As of April 2025, ChatGPT has nearly 800 million weekly active users and around 122.58 million daily users. In March 25 alone, ChatGPT website recorded about 4.5 billion visits, which was 3.9 in February. ChatGPT processes over 1 billion queries every single day. So this is a top view on the numbers that we are looking at. Hence, in conclusion, ChatGPT's global usage reflects diverse adoption patterns influenced by factors such as digital infrastructure, education, and cultural attitudes towards technology. United States and India are leading contributors, while countries like Kenya and Brazil demonstrate significant engagement, highlighting the widespread appeal and utility of AI driven conversational tool across different regions. ChatGPT is not just a tool, it represents the transformative shift in human computer interaction. By simulating nuanced conversation, it offers new opportunities across education, businesses, research, governance, and healthcare. The need for ethical deployment, robust governance, and continuous learning cannot be overstated. Yet, its powers comes with responsibilities. As AI continues to evolve, ChatGPT and its successor will shape how we work, learn, and communicate in a digital world. With the right balance of innovation and oversight, ChatGPT could become one of the most empowering technologies of 21st century. With this, we come to the end of this series. So this video had two parts, part 2 and part 3. Part 3 is an addendum covering the data centers space. Again, I like to thank you for being patient with me. Hope this videos have been useful, informative. If so, do share with like-minded people. If you like it, do subscribe, like, comment. If you have any queries, I'll try to respond as much as possible. This is your host, Savit Vittal Salian. Thank you, and let's catch up again with a new video.